right, so thank you for joining us for our senior design presentation. We're really happy to be here. I am Dalila, and this is Andy, and we will be presenting for our senior design project for the Department of Special Education, Empowering Voices. So a little bit about the company. They are an alternative and augmentative and alternative communication translations lab, which is directed by Dr. Kevin Pitt. And it is dedicated to advancing communication to individuals that need those devices. And their lab focused on developing brain and computer interface technologies alongside AI, or artificial intelligence, to help create a more intuitive, flexible, and emotionally responsive AAC systems.
So we kind of just want to introduce you guys to all our stakeholders. First and foremost, our product owner, also the director of the AACT lab, which you might have just heard recently, Dr. Kevin Pitt. We also have our subject matter expert, who is also the director of the SCAD lab here at the university, Dr. Sierra Ousley. We also have our user representative, an assistant professor here at the university, Dr. Sierra Kirkpatrick. And we also have our industry advisor, senior VP over at Smartbox, Dr. Chris Gibbons. And some more stakeholders, we have our project manager Jane Ohaya. We also have our tribe lead, Dr. Bonita Sharif, and also our industry coach, Bethany Wiles.
And to introduce our student team, we have Andy Trong, Ethan Friedman, and Brick Stein, as well as Riley Jaimes, Jason Irwin, and myself, the squad lead and product manager, Dalila Teva, I go by D, and then Jason Irwin is also our development manager.
So senior design kind of came to us with one big problem, which is that current AAC devices right now are very largely limited to static or pre-programmed vocabulary and a very neutral robotic voice output. And in a case of real-world communication, this is really difficult, especially for their users to express emotions. In this case, their users are children who have special needs and also have a speech-language impairment. And so as a result, communication is very difficult, even with these AAC devices, regarding any kind of emotional nuance. So things like urgency or anger aren't conveyed very well. But with this problem came a bunch of different actual opportunities for us here at the senior design team. One big thing was that our team was able to design a prototype application with features such as emotion detection. So things like a deep learning convolutional neural network model was trained for this application to be able to detect the 5 basic emotions: happiness, sadness, anger, surprise, and neutrality, based on a child's user expressions. Or adaptive vocabulary, which also plays a part within that emotion detection up there. So if a child is feeling angry, our prototype application will also show up angrier words to then better express their communication to those outside of them. Along with this, there's even more opportunities as well, such as emotional expressiveness in communication. So things that we were also able to implement using 11 Labs' most recent voice model, version 3. We were able to edit that emotional output that every child can have. So in this case, if that child was feeling angry, they'll type out that emotion, and then when they send that voice output out, it will also read it out in an angry tone. And the last thing with this new prototype design, we were also able to have a more user-centered design. So adding new features in, like a one-button expressive output button, or something like a simplified UI that kind of allows for that barrier of entry to be kind of decrease for children who are just getting into these AAC devices.
Okay. And then with that, I'll get started with showing our product and what it looks like. This is our start screen. This is what the user is first greeted with when they start up with the application. This allows you to navigate to any part of the application. Our main screen, this is where the user spends the most amount of time. This is where the emotion detection happens. This is where the voice is read out. And this is where the user is typing out what they want to say out loud. And so we have a couple options here, and we have features, the like intensity slider, and being able to turn off the camera and selecting your own emotion if you want to like not have it turned on. And then our calibration screen. This is our pride and joy of our application. This allows us, the user, to to train the model to detect specifically for their face and for their emotions. So however they express their happiness or surprise or sad, you can train the model locally to do so. And so this calibration screen allows you to, it's also very modular. So you're not stuck here sitting through 25 photos or more, or You can do it per emotion, and then if you need to pause even for that emotion, that takes 5 pictures, 5-second countdown per each. You can pause it at any time. You can go take a break, come back, and it's all saved. And this allows for more mobility with training the model. And then finally, we have our debug screen. It's more like a window. It runs in parallel with, you can run it in parallel with any of the 2 main screens that we just showcased. And it shows like it's primarily for the debugging purposes. It showcases all of the feedback from the application and what's going on. We also have our configuration, just showing how much space the application is taking, what's the uptime, how much CPU it's using. The main tab from this screen that a user would use would be the settings screen. This allows you to modify the voice. So you can select 2 male voices out of the 2 male voices or out of the 2 female voices, and you can adjust the variability or the style of the voice with the 2 options here, which adjust the speed and the variability. So.
Yeah, and this project has really given us a bunch of different values and highlights that we were able to take away. Some of the biggest project highlights so far was that we were able to create an updated standalone application. While yes, it's still in the prototype form, it's still some kind of future, what the future could hold for these AAC devices. Another big thing was being able to train a new and improved deep learning model, just something which hasn't really been done in this field specifically. And another big thing is probably also our crown jewel, in our opinion, is integrating that emotion-aware voice output. So having that voice sound angry, happy, or sad, and things of that nature. And with these highlights have also brought really cool results for us as well. So things like a really high calibrated model accuracy. So post-calibration, we found that we can range from anywhere from about 85 to 90% accuracy in detecting these emotions. And another big thing is, again, this application to be able to showcase the usage of our deep learning model with also integrated within common AAC features as well. And lastly, this project has really given us so many learning opportunities that we are just so happy to be able to achieve. So things like practicing the Scrum framework, or like things practicing professional communication within a professional meeting setting, project planning, being able to train AI models. Some of us got a lot of experience with desktop application and deployment. One of them you're looking at right now. And also just kind of really hardening our skills within the software architecture designing as well. With that, we just want to say thank you so much for coming to our presentation. If you're really interested in what we did, please, you can always check downstairs at that second floor to check out our application. You can also vote for us here for that People's Choice Award.